Hi, I'm Bob Ward from Microsoft, a principal architect in the Database Systems Group. I'm here today to talk about how SQL Server 2017 is built for performance, requiring less tuning and configuration for developers, allowing them to focus more on the data application. Now, in today's video, we're going to talk about several topics and do some demonstrations. First, we're going to talk about how SQL Server is built in to be scalable. We're going to introduce you to two new features in SQL Server 2017 called Adaptive Query Processing and Automatic Tuning. And we're going to conclude by talking about how we believe SQL Server is the fastest database on the planet. Now, we want developers to focus on their application, but also achieve the scalability and performance they need. That's why the SQL Server database engine is optimized to detect and run on high-dense core CPUs, on the fastest I/O drives in the world like NVMe SSDs, and high-speed networks. If you'd like to learn more about some of those capabilities, check out our popular blog series called It Just Runs Faster. For applications that need analytic query performance, simply add column store indexes and get unmatched performance for analytic workloads. And SQL Server is designed to detect a multi-CPU system and scale up and scale down as needed, so we run your queries in parallel as needed, and even maintenance jobs such as index rebuilds, backups, and database recovery. Now, we want to keep your application tuned as best as possible, so we offer automatic statistic updates for your indexes to ensure your query plans perform the best they can in your environment. And we even offer recommendations on what indexes may be missing for your workloads to give you an extra boost in performance. Now, SQL Server 2017 is all about choice. So we have proven performance whether you're running on Windows, your favorite Linux distribution, or even on Docker containers. Let's take a second to see how well SQL Server can perform tuned free, even on a laptop. So you see on my screen here in front of me, I'm using the popular open source benchmarking tool called HammerDB, running the TPC-C workload, which is an OLTP workload. And I'm going to demonstrate to you on this laptop running SQL Server 2017 with no tuning configuration changes. On my laptop, I can achieve 1 million transactions per minute. So let me kick this off and see if I can measure its performance. You can see very quickly, I've already reached 900,000 transactions per minute, and you'll see quickly it'll exceed to 1 million. See, I'm already at 1 million. And so you may be asking yourself, why is it a big deal as a developer? Well, this is actually a standard workload that runs a combination of insert, update, deletes, and select statements, so you can easily run this tool to gauge how will SQL Server perform on my machine or in my environment. Now, another really handy thing to show while running this workload is a new feature of our Management Studio tool called XE Profiler, where I can click here and quickly live trace all the queries that are running with my workload. In addition, I can use another tool provided in SQL Server 2017 called Query Store. So I can look here at the Query Store and see my top resource consuming queries. So you can see here on my laptop, I'm actually running the client for the workload, the actual SQL Server engine. I'm tracing live queries and looking at our Query Store, all while still maintaining almost 1 million transactions per minute. This kind of proves to you as a developer that you can even use our diagnostic tools using a tool like HammerDB and see you can stress SQL Server, still use our tracing tools, and still achieve the performance you'd like to see in your environment. So that's just a brief taste of how fast SQL Server can be. 1 million transactions per minute, all running on my laptop. You know, queries are the lifeblood of any data application. And in SQL Server 2017, we've introduced a new feature family called Adaptive Query Processing. And you see on the screen here some examples of what that feature family looks like. This is just the beginning of a journey for us to build an intelligent query processor that adapts to your needs versus you spending countless hours debugging queries. Let's go look at a demo of Adaptive Query Processing. I have in front of me SQL Server Management Studio, and what I've done is taking the Wide World Sample Importers database and added a new sort procedure to show off the power of Adaptive Query Processing. Now, this particular procedure right here, when I run it, is going to involve something called a hash join and a sort operator. These operators require something in SQL Server called a memory grant. It's memory for the execution of the query. And what can happen in some cases with query processing is the query processor will not actually allocate enough memory for one of these queries, which requires us to page some of the memory to disk in something called tempdb spills. This can affect your query performance. With our adaptive query processing, we have the ability to actually recognize a situation like this, and without recompiling the query plan, adapt and adjust and give the proper memory to the query in its next execution. Let me show you how that works. So we'll run this query here. I'm actually using this feature called Actual Execution Plan so I can see what the plan will look like after I'm done. So let's kick this off. And you'll notice here it's starting to run here. This query is actually going to take around 8 to 12 seconds to run, and that's because during the processing of the query, we're doing what I told you about, these tempDB spills. So when the query finishes, I can take a look at the execution plan, and you'll notice at the bottom down here, I see these warning indicators in the plan. Those are indicators of this possible tempDB spill scenario. If I zoom in into the properties of the plan, you can see the actual warning. You can see the fact that tempDB a spill had to occur to disk for tempDB, and this is indicative of one of these memory grant type problems. So I'll simply just turn around and run the query a second time, allowing the query processor, which have already gotten feedback that this memory grant was insufficient to run, and see how it executes. So let me run it a second time, and if you'll notice, the query comes back in actually less than 1 second. And if you look at the execution plan now and you zoom in, you'll notice there is no more warning of an actual sort spill because what SQL Server has done is ensure that the proper memory grant is given the second time around. This is just a small but simple example of our intelligent query processor and adaptive query processing feature in SQL Server 2017. Once you deploy your application and get the performance you expect and need, unexpected events can occur in your environment that cause a degradation in performance. One such example is something called query plan regression. We've introduced a feature in SQL Server 2017 called automatic tuning. Powered by Query Store, automatic tuning can detect, recommend, and even automatically fix these query plan regression problems. Let's see how automatic tuning works in action. In front of me is a performance monitor chart measuring the throughput of my workload in the form of batch requests per second. Now I've modified the wide world importer sample database by adding a stored procedure that takes an integer parameter. And that particular procedure will run a query against one of the tables in the database. So I'm going to kick off this script, which uses the popular stress tool called ostress to run multiple users running that stored procedure. And you can see here I get a certain throughput of batch requests per second. Now let's introduce a regression, a query plan regression problem with a phenomenon called parameter sniffing. And I'm going to run this script. As you see, the throughput of batch requests per second goes down drastically. Now imagine you're in the middle of the night at home getting a phone call, emergency phone call on a problem like this because of this performance problem, and you're not sure what to do. Well, in SQL Server 2017, by default, we have a dynamic management view that you can run in your database that when it detects a query plan regression problem, let's get the right database context here. When it detects a query plan regression problem, it can actually tell you that here's a script you can run to fix the problem. So if you got called in the middle of the night, you would detect this problem with our new feature, automatic tuning, and you would then go fix the problem, and we would revert to the query plan that actually was running great for the workload before the performance problem occurred. Well, let's say that you'd like to go a step further. With automatic tuning, we have an option called last known plan force good. So you can actually have the system, instead of detect and recommend the problem, automatically correct it for you. Let's take a look at what that looks like. So I'm going to clear my perfmon chart. This script right here is going to turn on the automatic tuning feature, and let's make sure that we've got that enabled. Let's go back and run the same exact scenario again and see what happens. So I'm going to kick off my workload. I can see in perfmon here that I have a certain batch request per second, a certain steady rate. I'm going to introduce the regression again, and you're going to notice on perfmon that the performance goes down, but within less than a second, the performance goes right back up. Now, what has happened here, instead of SQL Server recommending to you what to do to fix the problem, we have automatically applied this fix. If you go back, look at this dynamic management view again and run this query, you're going to see that now we have a state called last good plan forced. So again, this is a scenario where you would not get called in the middle of the night. Instead, you would come to the office the next day and maybe receive an email that a small blip in performance had occurred, but everything seems to be good again. Now you then can go use our Query Store tool, which I'll show you here, to go look at your top performing queries. And then you can see here with this checkbox here how the system automatically forced a plan that was previously a good plan and resulted in great query performance. And then you can do your investigation at your own time. So that is automatic tuning in action. Again, the default behavior is to detect these problems and then recommend to you how to fix the problem. And then if you'd like to, you can turn on the full automation where we'll detect and actually fix the problem for you. You know, we believe SQL Server is the fastest database on the planet, whether it's in your cloud or ours. We've demonstrated this by showing world records in analytic and OLTP query performance. We've even demonstrated how easily we can handle scanning tables of billions of rows in seconds. And we continue to be the leader in price performance, recently partnering with HP Enterprises to show the world's first enterprise-grade diskless database using HP's scalable persistent memory technology. I hope today you've got a flavor of some of the amazing performance enhancements we've made to SQL Server 2017. We showed how fast it can run on a laptop. We showed you features like adaptive query processing and automatic tuning. And if you'd like to get more information about how great the performance of SQL Server 2017 is, take a look at our blog or install it yourself and see how fast SQL Server 2017 can run in your environment. Thank you for your attention today.